It was great meeting with all of you guys earlier today to discuss your projects. I'm super excited to see how many responses a lot of you guys have received. The feedback has been great. I'm excited to.
I think your Wi-Fi glitched out a little bit there.
No, can you not hear me again? What happened?
Was that me, or did you guys also have that?
I didn't either.
You can't hear me?
We can hear you now. Like, we can hear you. It's just like at the end of like every sentence, it's like there we go.
Okay. All right. Well, we're just gonna power through. I don't know what else to do. It did it again.
Yeah, but we're powering through. It's okay.
Okay. Sorry.
No, you're all good. Power through.
So
Also, the clouds look really nice for McKenna. Sorry to sidetrack. That just looks really good.
Oh, that is pretty. So the goal again is for you guys to recruit 20 participants per group member. So if you have a group of 3 people, the aim is to get around 60 participants. If you have 5 people in your group, you should be close to 100. So if that is proving to be challenging, please double your efforts. And by that, I mean email fellow classmates in this class, email classmates in other classes that you are in here at Aquinas. You can double down on social media requests. You can ask friends to see if they have other friends at other campuses that, you can use a snowball effect type thing. Again, the goal is each of you needs to be contributing in getting data. That's what we're working for. So if that continues to be an issue, please do let me know. Ultimately, we want to start analyzing the data as soon as possible because your results section is going to be due by Wednesday, end of day Wednesday next week. Now, I want to make sure that everybody knows what they're looking for. This needs to be on this side, not over here, but this one. Let me just pull up here what it should look like. And for the bulk of it, I have, I covered it with you guys in the class. Why is this not sharing? I don't know what the question is here, Noella. You're asking about a group link?
Yeah, for the other study.
I just included a link for our survey.
Oh, I seen the other one. I already took that one, I think.
Okay.
Yeah.
Thank you.
Okay. I don't know what the other survey is then, Noella. All right, let's talk about this real briefly. So is everybody seeing this?
Yes.
Okay. So the results section, it needs to be in an APA formatted table. And this is where you will write up the results that you have found in terms of both frequency and mean and standard deviation. Now, I have told several of you already, but I just want to reiterate. You see how this is just an example I found online. You see how it notes standard deviation? I would not write that. I would instead write a capital M for mean, comma, oh boy, that's a comma, SD for standard deviation. Because this is what you're doing, right? So like the age value here, this is the mean, and then this is the standard deviation. So for many of you, you will not have very many variables, if any, that fall in this category that are where you would be giving a mean and standard deviation. Age is definitely going to be one of them. And for some of you, if you had a scale that was like from 1 to 5, how did you feel about whatever, you can create a mean with that. That's okay. Even though it's a categorical data, that's all right. So, and then you could create a standard deviation with that as well. If you need help to figure out how to do a mean and standard deviation, please email me, let me know. I'm happy to help you out with that. Mean should be fairly straightforward. Let me just pull up, let's turn this off here. And actually, I take it back every time I do that. Let's erase this. Okay. Okay, a mean. Can you guys see Excel or no?
No.
Do you see it now?
Yes.
Okay. I just picked, that's not helpful. Make sure you don't have COVID, buddy.
Oh yeah, I know.
Personal experience.
I think my allergies are just acting up because I live in the woods and a lot of pollen.
Oh, yes, that's definitely been an issue. All right, so this is one of your group's responses. We're just gonna go with it here. Actually, it may be my other section. But the way you would calculate a mean is highlight all the responses. This is for age, right? Okay, highlight all the responses. And if you are in Excel, here you go. It says right there, 20.04, okay? Right there. It gives it to you. Now, if you're like, you forget that, that's okay. Come over here, create a new cell. You would write equal and start writing average. Okay, hold on. Are you okay? Yeah. What happened? Hold on 1 second. I've got kiddos on spring break and now something broke.
Okay.
He just broke a dish and he was very sad. Okay.
Aw.
So if you look over here, you would do equal AV to start spelling out average. Here it is down here, returns the average of its argument, right? Double click that, and then you just highlight that entire section. Close the parenthesis. And there it is, same number, 20.04. Okay. If you want to know how to do the standard deviation, you do the exact same process. See how over here we did equal and we typed in average. Instead, you would do equal, type in ST, and in fact, let me show you. If you do equal and you start typing in standard deviation right here, STDEV.S, that is the estimated standard deviation for a sample. Okay, you would click that. You highlight all that same info again, close the parenthesis, and here you are. Standard deviation is 1.45. Okay, so that is how you can analyze your data. Moving back to our Course Connect page, the biggest take home is that this needs to be an APA format. If you're not sure how to do that, look up an APA guidebook. It will walk you through how to do it. Ultimately, you need each variable listed, and then every possibility needs to be underneath it. So if for gender, your options were female, male, maybe you had a non-binary option, maybe you also had a prefer not to say option, whatever the options were, they all need to be listed. And then in this N category, you would write how many counts, how many frequency, how many females did you have, how many males did you have, things like that. Okay, then you would write the percentage. I went through that with every single group, so hopefully this is not something that's too challenging. Again, I just want to reiterate, if you guys want to divide and conquer, one person covers some of the mean standard deviation stuff, the other person covers more of the frequency, totally fine. That is absolutely a-okay to me. You will each need to submit your own results section, but it's okay if the information is the same because data can't change between one person and another, right? Now, the only thing that if you might need additional information is if you have specific analysis you'd like me to run, where maybe you want to know what's the difference between, males and females on this response, let me know and I'll do those more sophisticated analyses and send it back to you.
Awesome.
Okay.
Thank you.
All right. Any questions about that, the results section? Quick reminder that is due by
No, I think I was.
next week, Wednesday. So that means the April 14th by midnight, that needs to be completed. Okay. All right.
Awesome.
Moving right along for today. Oops, I just passed it. I just want to check in. We finished chapter 11, right? Last lecture, we wrapped it up, right? We weren't halfway through. I'm pretty sure.
The last note I have is selection. Yeah, I think so.
Okay.
We were doing like combined threats.
Yep. Yeah. So I think that's all of it. Let me just double check now.
Ooh, no, we did part 1. We did chapter 11, part 1.
Okay. Did we talk about attrition threats? Yeah, we did all that. And we went all the way up to combined threats? Like
Yeah.
selection history and selection attrition.
Yeah, we had
Oh.
history, regression, attrition, testing threats to internal validity, instrumental threats to internal validity,
Yeah.
and then combined threats.
Okay. Well, I'm glad I asked because we have to finish that then. Okay. So let's do this. That. You guys are seeing this big slide, right?
Yep. 3
Okay.
potential internal validity threats.
Perfect. Okay. So just briefly, we just finished talking about the combined threats, which are, again, in the real world of research, it's rare that you only have one type of threat. It's quite often that you have a combination of both. So for instance, this selection attrition threat, if participants in your experimental group are severely depressed, and that's in part why you selected them, there is a greater risk that they'll drop out of the study. So there'll be greater rates of attrition because of just the nature of how you selected them. So again, that can be common where you have more than one threat to the validity of your study. The next section we go into are, again, separate threats to internal validity that can be found in any experiment. So the first one we talk about here, and let me get my pointer because this is working. Here it is. The first one is observer bias. Okay. So this is when the fact that you are being observed leads to a participant behaving in a different way than they would traditionally. This happens quite often, happens in the real world. It's very much of a social pressure piece, right? If you are being observed as you're doing something, right? I don't know why this popped into my mind, but if you're in the produce section and you're looking at cantaloupe and people are staring at you, you may like get more scientific, like, oh, well, I, shake it or smell it or press or wait, as if you know what you're doing. And maybe some of you guys do, you have a good strategy on picking the best cantaloupe. But your behavior is inherently different because you are being observed. That immediately poses a threat to the internal validity of your study because the individual, the participant, is no longer behaving the way they usually would, right? There is an impact because of social norm. All right, so some of the examples, again, it's if also part of the observer bias is when the researcher's expectation are influencing the way you're acting. So if you expect that your new reading intervention is going to be successful, you may also be biased towards participants receiving that intervention in terms of their reading ability. So that observer bias is present as well, which would threaten the internal validity of your study, okay? Demand characteristic is slightly different. That's when the participants figure out what it is you're trying to get them to do, right? They figure out what is this research study about. And so then their behavior is then impacted. They change their behavior to match what it is you're looking for because they have inherently figured out what the study is about. That is demand characteristic, okay? The way we control for that is, again, through a double-blind study. So that would be neither the participants know whether they're in a placebo group or an experimental group. and the researcher also does not know, okay? So the researcher is not aware who is getting what, so that their interpretation of behavior is truly objective and not subjective to what they think or want to happen. Okay. And then a placebo effect. Obviously, we all know about the placebo effect. What does that look like? What is the placebo effect?
It's when someone believes they're getting like the active agent or like the positive part, and so then they like their health or whatever performs better, even though they got like just the placebo.
Absolutely. So it's this idea that I am part of the study, and if I am given something, that must be the treatment. And psychologically, I am expecting my symptoms to reduce. Usually it's a symptom reduction in experiments. And therefore, because of that, I'm taking it, I am believing that I am changing, when in fact, it's either a sugar pill. I think we've talked about this before, like it could be just an IV with saline. So again, that's what's going on with placebo effects. So let's look at some additional examples of placebo effects. You can design studies to rule out that placebo effect, and the way you would do that, again, is through a double-blind study with a control group. So again, if the fact that you are part of the study is going to alter your belief as to whether you're getting better, you need to control for that, right? So if, for instance, a participant is told that they're receiving a new therapy, but it's missing, just like McKenna said, it's missing the active ingredient. So it is just, like a sugar pill or saline, like we talked about. But you're also being told that you're getting this new kind of therapy. You may believe that you're improving because of it. So to rule out that placebo effect, you can create a special comparison group that's receiving the placebo therapy, but neither the people working with the participants or the participants themselves, and usually with placebo, the participants never know that they're getting a non-active version of the medication. But again, this idea of the double blind is no one knows, right? So you are simply recording symptoms. So as the researcher, I don't know if you're getting the actual medication or the placebo. So I'm being more objective in my recording. Okay. So if you can see here, the figure on the left, you can see that both groups had decrease in symptoms, right? The placebo therapy and the true therapy both experienced decrease in symptoms, just in general. But the group that's getting the true therapy improved more than the group that's only getting the placebo therapy. And that suggests that therapy on its own has some effect. Then you can look at this graph over here. That shows that there's a placebo effect, but now we're also using a control group that has no therapy at all. So this would suggest that somehow getting even a placebo is better than getting nothing at all, right? So you're seeing here, there is some level of improvement because of maturation, when we talked about that, I think last week. So just because there is time progressing, right? There's movement over time, that has created this decrease in symptoms, but you see a much more significant decrease because of the therapy that you're receiving.
No question. So do they try these like placebos on more serious like diseases and illnesses, and like to really gauge if it's like, oh, here's this groundbreaking cure for cancer, does it like have they recorded? Because like I know ethically that's kind of like no-go, because it's like, yeah, you're just lying to this person.
Yeah, I think that's the dangerous piece, right? It's the ethics. If we know the course, I mean, if you think back to syphilis even, right? In the Tuskegee experiments, they knew the course of syphilis could eventually be death and massive spread amongst the community, right? So the control group of not doing anything is causing active harm. Even if you gave them a sugar pill, this is not just therapy where you're like, oh, I'm feeling less depressed. This is like eating through your insides. Biologically, there is significant impact. So I think for something like, more intense or more significant or more serious, illnesses, ethically, it wouldn't be right to just do a straight up placebo.
Well, I just didn't know if there were any more of those like syphilis ones, like before ethics was really looked at, like where
Right.
they were like, yeah, well, we did a couple.
Right. Well, and that's just it. Like it is a challenge with that. We know psychologically there is an impact. There is going to be this view of like, yes, I think I ought to get better. And you can look there also at the introduction of like spiritual factors and how that can help treatment. But it's usually done in conjunction. So it's an additive type of treatment. So you add this in or you don't. It's not, we take away the thing we know will help. Does that kind of make sense?
Yeah. Because like again, I'm just like, but also here's this pill that's supposed to like really accelerate the treatment.
Yeah.
Okay.
Yeah. I mean, I think then you would open yourself up to a lawsuit because the individual would
Yeah.
go, well, I thought this was a brand new treatment that was going to be super effective. Turns out you're just giving me sugar pills and now I've got diabetes, whatever it is, something else could respond.
Yeah, on top of everything.
Exactly. Yeah. So, I mean, if you guys remember the Goldacre TED Talk, that's one of the things he talks about is that it is not fair or not ethical for researchers to try their new medications against a placebo, right? Which of course is going to show better versus the new medication versus the old medication. We already know this old medication works and is somewhat effective. Why not compare it to that rather than nothing, right? Or a placebo. So, yeah. So placebo effects, yeah, it can be real messy in terms of ethics. So ultimately, with so many threats, are experiments still useful? The answer is yes. Experiments definitely play a role. You just have to be very mindful of all the possible limitations and pitfalls that found themselves within studies. So especially when you're doing more sophisticated experiments. So the next few slides are just a good refresher as to all the different types of internal validity threats that we discussed. You'll see the definition, a quick example of where you can find it again in the textbook, and what questions to really ask yourself to try to reduce as much as possible the impact of that internal validity threat. So again, there's several of these slides here that you guys can use as a guide when you're studying. Okay, now we're moving into interrogating null effects. This is a conversation I have with my doctoral students all the time, which is, I ran the study and nothing was significant. I could not reject the null hypothesis. So why did I waste my time? Nothing is meaningful. How do we feel about that?
I feel like even if it's not significant, it's still meaningful because there's your answer,
Exactly. You're spot on. So it's not because you don't get a statistically significant result that it is not still an interesting result and a result that moves science forward, right? And even if you do have some sort of non-significant result, sometimes it's an opportunity to go back at your research design, go back at the way you collected data so that you can then discuss the limitations of your study and help future researchers with some ideas on how to improve things. Okay. So if you are getting what appears to be a no difference between groups or a result that would support your null hypothesis, it's possible that there's not enough of a difference. So maybe your participants, there's something about the recruitment that was idiosyncratic that doesn't show this more generalized difference that should have been perceived. It's possible that there's within group variability that is really hiding or obscuring the group differences. It's also possible that flat out, there's no difference, right? Like if I said something absurd like, do Aquinas students with brown hair get higher grades than those with blonde hair? Completely nonsensical. I would certainly hope that there'd be no difference there, right? Because there's no link. It doesn't really make sense. So, you know, if that does happen, I'm going to shoot a quick, do you guys keep seeing me freeze? Are you seeing
A
me?
little bit, yeah.
I keep getting
Yeah.
messages that say my internet is unstable.
I mean, I just got one that said my internet isn't stable.
Okay. I'm just gonna see if my husband can try to fix that. Okay, so let's dive into what that would look like. So let's first, when an independent variable shows that there's no difference, right? Doesn't seem to impact it one day. So let's look at this first example. So this is a fun one. This is the results of participants as to how they reported their level of happiness on a mood scale. Okay. There's 3 different conditions. So they were asked, how happy are you? And they didn't receive any money, right? Then some received some money and they were asked, how happy are you? And some received a lot of money. Okay. So those are the 3 conditions: no money, a little bit of money, lots of money. What may you deduce from this graph?
That money doesn't affect happiness significantly.
Okay. Yeah. That the amount of money or any money at all doesn't seem to have that big of an impact. What might be a question you would want to know, or what would you be curious about? Like, let me take a step back. Are you surprised by this finding?
Kind of, but don't like, so like your like the question that would be the easiest to indicate what's happening is, where do they get the participants and what socioeconomic like bracket are they in? Because if they're all super like wealthy, giving them money isn't matter, it doesn't really affect them.
Right.
But if like, you know, some are homeless, everything's gonna make them like, it's like, oh yes. So
Right.
what bracket are they getting?
Okay, good. What are some other ideas, gang? Are you surprised by this? Anybody go like, oh, that's not what I would have expected?
I will say, yeah. Like, if someone gave me a lot of money, I'd be a lot more happy, I guess. I'd say.
Yeah. Anybody else? Come on. Money and happiness, that's a fun topic. Nothing.
How would you define happiness, you know? It's it's like, I guess stability maybe could equate to
No, well, so I mean, again, like if this isn't a scale that looks like how happy you are, whatever that is, like, do you smile a lot? And you have these conditions, and you're seeing no change in any of the conditions. I would suspect the researchers of the study would have hypothesized that the greater the amount of money participants received, the greater
Yeah.
the, right? Like that just, I think, is the go-to most logical explanation, especially in this society. We value money. It's just how it is.
right.
This data does not support that.
Right.
Right. All right, let's look at the next graph. Okay. That is the score participants received on the GRE. And that is whether they received a prep course or whether they were given a really strong pep talk before the test. What do we think? What is this telling us? Which one impacts it the most?
Okay, question. What's the GRE?
Oh, it's
For
the
grad
like
school.
the SAT, but for grad school.
Okay, cool.
Standardized tests, but it's if you're going to graduate school, like to get an MBA or doctoral program, it's different than if you're going to medical school. Then you have to take the MCAT, I think is what it is, or if you're going to law school, I think it's the LSAT. But anyway, that's for graduate school.
Okay.
So what do we think? Is it worth the money? Not graduate school, but the prep class.
No, the scores seem kind of the same, even if you had like just a pep talk or the prep course.
Right. How much do you think you'd see that on an advertisement? Pay me $1,000. I will help you, master the GRE, and you will get 6 points more than if I give you a strong pep talk, right? Like they would be like, bury that information. We don't want people to know. We still want them to give us their money, right? Okay. All right. This last one here is whether having anxiety or symptoms of anxiety impacted scores on a logical reasoning task. Okay. And what is this graph telling us?
Very
That
conf-
people with
I
high
don't know.
anxiety,
It-
that high anxiety will impact it at least a little bit more than lower medium anxiety.
But it's like pretty minimal, right? I mean, this
Yeah.
looks to me like it's maybe like
So-
1.3 versus 1.1, like fairly close together. Okay. So this would be another one. Like being super anxious does not mean you'll perform worse than being just a tiny bit anxious. Okay. So in all of these graphs, there is a null effect. That means the independent variable didn't really impact the dependent variable, because as we can see, the different levels of the independent variable showed no difference. Okay. But it could be because they have nothing to do with one another, or it could be because the study wasn't designed appropriately, or that the independent variable wasn't measured adequately either, right? There's several questions that can pop up, and we'll dive into why that might be right here. Okay. Excuse me. So I just kind of talked about this already, but it's possible that there's just weak manipulation between the different levels. There could be insensitive measures, right? So if in the possible experiment, do you guys remember that? If the scale that I gave people was only measuring pounds and not ounces or grams, it might seem like everybody's like 1 pound and 1 pound, and here's another pound, right? Like, and not actually differentiate between 1.0 pound versus 1.99 pounds, right? That would be a larger difference. It could be that there's ceiling and floor effects. And again, we're going to dive into all of those individually. And then it could be that there's a design confound that's actually acting in reverse. So somehow the confound is actually leading to work against the experimental effect. So we'll talk about that again in just a second. So these are some ideas that you have to kind of think through. So first, when you think about the ceiling and floor effect, the ceiling effect is that the scores max out and you end up having this cluster of scores that are all at the high end, okay? So if you are trying to assess academic achievement in college students, right? And I decide, well, I'm gonna use my research methods class. I think they're pretty smart cookies. And I give you all my 3rd graders math test. I'm gonna be like, look at me. They're brilliant. They all scored 100, hopefully, right? That would be a ceiling effect, meaning almost every single score is clustered around the top. Similarly, a floor effect is this is so hard. They have no clue how to respond, and all the clusters of scores are at the very bottom, right? They're at the low end of what I would expect, okay? If you give a test of, simple vocab to a group of individuals who are English speakers, and the vocab test is in Mandarin or Spanish or some other language, you are going to get a large cluster of scores that are extremely low because it does not adequately assess their skill, right? There's a confound in there. You introduced language that had nothing to do with it, okay? So ceiling and floor effects can be the result of a problematic independent variable, okay? In the money and mood experiment, all 3 levels of the independent variable were low. So what if in that example, as for money, one group for money had no extra money. The slight amount of money, I gave them 25 cents, and the other group, I gave them $1. Do you think that would impact their overall happiness?
No.
No. Now,
No.
there's an exponential growth, right? Like between a quarter and $1. But those are such minute amounts. They are almost inconsequential, right? You're like, that's not gonna.
Oh, another good thing would be to ask about age. Because like if you're giving a third grader, $10, it's huge.
Oh man, I feel like is my third grader there? No, he's not. My fifth grader's here. They'd probably be like, I have told my children,
No.
I will give you $10 to go weed. No, $20. I'm like, this is highway robbery. I could get an unskilled, somebody, a high schooler, I think would take $10. Fifth grader. Anyway, so yeah, yes, age probably would play a big role into that as well. Socioeconomic group, that was a good differentiation also as well. So again, it matters how you're comparing each of the levels. That will have a massive impact. For the anxiety and the reasoning experiment, if all three levels of the independent variable were actually high, in terms of how anxious they felt, they all received a high level of shock. It was a weird study. You can look at it in your textbook, but that's what was making them anxious, right? Is whether they're going to receive a shock. If that is all the same, then their response is going to be bad regardless of their level of anxiety. That's what they're focused on. Okay, manipulation check. So it's in the second, if you have a second dependent variable that's included in a study, you want to make sure that the independent variable and how you manipulated and created conditions around it, you want to make sure that that actually worked. So what you show here on the left, we've got our different anxiety groups, low, medium, and high, but it didn't actually work all that well. It didn't seem like the manipulation was effective because our response, our results to the dependent variable were all very similar. Now, it's possible one of the reasons why that might be is that people self-reported their level of anxiety, and it may very well be that they didn't adequately, reported where they were within that, versus the second group where it seemed to differentiate the three groups better. And one of the reasons is that instead of having it be a self-report measure, maybe this was done by a psychiatrist, right? Like grouping people as to where they should be. Or maybe the scale that was used was more adequate at really fine-tuning and differentiating different groups. So that would be a manipulation check. Confounds in reverse, so confounds, we talked a lot about that last week. Usually they threaten, that's where the issue is. They threaten internal validity. It can also apply to null effects. So in the GRE study, this was funny. It's possible that the test prep group was more stressed out than the pep talk group. Because if you think about it, if you spend the money to be really, really, really prepared for this exam, there's additional pressure on you to perform, right? So that additional pressure will likely impact your ability to score well compared to the pep talk group that's like, I'm just going to go give this a try and we'll see what happens, right? Very little pressure, external or maybe even internal. So I feel like that's a good life lesson just in general to not get too freaked out, because if you get in your own head, that impacts your results as well. So the additional pressure that was found in the GRE prep group, that would be considered a confound, but it didn't work in the favor that the researchers intended it to, right? Because they wanted to show that the test, I'm assuming here, that the test prep prepared students so much better that they received higher scores in the end. The confound of additional pressure worked against the experimental group in this, which was receiving the test prep. So, because it ended up lowering their scores. Again, we talked about this a little bit a couple of weeks ago when we talked about the pasta example, but if you're your big bowl condition, right? Like those who receive the big bowl, if all of those people had to go last, right? Like the medium bowl folks went first, so that your big bowl ended up going at 2 p.m. and everyone is starving, that the timing of the day would act as a confound, and it will perhaps work against the way they're trying to measure things too. So that's just another example of that, how confounds can actually work in reverse or against your experimental group. It is possible that there's within group variability that will mask between group variability as well. So if there's too much error variance, right, there's too much variance within your groups, it's masking the potential difference. They're calling this having too much noise or having noisy data is another way that is discussed. Okay, so you can see here the within group variability, right, ranges is quite wide. So look at this one versus this one. There's far more variance here, which is going to impact where it lands ultimately. Let's see, anything else I want to tell you about that? Some reasons why you may have that. It could be that you have measurement error. You could have individual differences that are just present. We'll talk about some of these in just a minute. This situation noise, like again, there's data that is not represented accurately. Ways to try to solve for that would be to increase your sample size. So whatever variability you have gets reduced. You can increase the difference in the levels of the independent variable if that's something you're able to do. You can use a repeated measure design like we talked about a couple weeks ago, so you could see if there's trends and patterns that are established. Or you could also do match pairs so that you're looking at groups that are more evenly split to take away any sort of individual differences that are experienced in each group. Measurement error. This sadly just happens, so we need to be mindful of it. So it's any factor that can inflate or deflate a person's true score on a dependent variable. So if you are measuring body temperature, for instance, and you decide I'm going to use the mercury thermometer, do you guys know those? Like it's like a glass thermometer sticking under your tongue. You might get different readings from the same exact thermometer depending on how the person is making the observation and viewing the thermometer. Because I don't know if you guys have seen those, but they're hard to see. You have to kind of like tilt them a little. Do you guys know what I'm talking about? Does anybody use? Okay.
Yes.
Yeah.
Because I feel like now the more commonly used thermometer is the forehead, the temporal one. Have you guys used that?
Yeah, or like just digital ones in general.
Okay. I think Christopher has a friend with him. The temporal ones I find to be incredibly frustrating. Have you guys like taken your temperature multiple times?
I used to do that when I was in high school. They'd always be like, "You don't have a fever," and I'm like, "I'm burning up."
Yeah, it is bizarre. Like I'm like, I feel like, man, do I have a fever? Especially this last year, we're all like, red alert, do I have a fever? It's like 96.3. Apparently I'm part dead, right? Like what is going on that the range of temperature, I feel like I've never gotten anything higher than a 97. So I'm like, this thing's broken. Or the one you could do the ear one, which they say is not quite as reliable either. So anyway, reliability, that's huge. In controlling for measurement error, you want to use whatever tool you're using to be easy for all researchers to be able to actually get to the same conclusion. And you want it to be reliable. Obviously, that's going to be a key part of it because you're trying to reduce error as much as possible. So the way you can do that is, I just said that, using reliable and precise measurements. You want to select surveys that are considered the gold standard within the field where you're looking. You want to make sure that there's strong construct validity as well. You want to make sure that whatever software you're using, if you're doing an experimental study, that it's shown to be reliable as well. That's not just going to lose your data. And you want to have participants who are engaged, right? So if you are doing a super, super long survey, you want to make sure that your participants are not like banging head against desk like, I want to be done with this. This is awful. You want them to be non-drowsy and engaged, right? Pretty key. Okay, another way that you can increase your validity and reduce measurement error is you can measure multiple times, right? So this controls for part of the historical context and threat that we talked about before, where if you take a measurement and there's something contextually happening to the participant that's causing a weird response possibly, then you can do multiple sampling. So it's grabbing larger samples, doing smaller sampling groups within that, and that tends to reduce random error. Okay. Individual differences. That's another source of within group variability. People differ. That's just kind of the bottom line, right? Some people are going to be smarter. Others are going to be, they're going to have different personality traits. Others are going to have different athletic traits. That is bound to happen. So in this particular study, this is again the money versus some money, right? These people received no money. These people received $1. Ooh, watch out, $1. Can you even get something from the dollar store for $1? Because don't they tack on tax? It'd be like $1.03 or something. Anyway, so in this particular study, you can see there's variability. This dude, Michael, is just a happy-go-lucky fella, right? Compared to this dude who's like maybe a curmudgeon. We don't quite know what the situation may be. So having those individual differences are going to be impactful. So the way we can solve for that, again, would be to have some sort of repeated exposure, right? So in this instance would be you get no money, take the mood survey. Now I give you $1, take the mood survey again, okay? So then you get to measure how much they're impacted by this particular experimental group, or the experimental condition, I should say. So that would be a within group design where you can swap again the conditions. You could also just add more participants. If it's not feasible to change the design to a within group or match group, you could just add more participant to see if there's any greater effects by adding more people. And
Now-
so this would be the
I just had a quick question. If you were to take the $1 back after you did the second time, like, what would you be measuring then? Because
well, it's like it giveth and taketh away.
exactly, because like what would that because like I gotta think that would decrease the happiness. It should be an
I
interesting.
think that would decrease trust, maybe more than happiness. Like,
because I was just thinking about like how this is just $1.
Mhm.
So like, how would you do it where like, it's a significant amount of money? Like, oh, here's $100. You're not just giving $100 to all these people. You got to get the money back.
So have you guys ever seen clips, and this occasionally will pop up on America's Funniest Home Video, I'm sure there's a ton on YouTube, of these folks who are given lotto tickets that are rigged, right? And they're like, oh my gosh, oh wow, like, oh, the scratcher, I got 2, they're the same. Oh my gosh, I got a 3rd one. I won $10,000. And then you see it, I mean, do you guys know what I'm talking about? Has anybody seen these videos? Okay,
No.
thank you, McKenna. So you see them jumping up and down, and then everybody's like, and then they're, oh, look at the back. Look, oh, pick it up at your mama's house. It's always something silly on the back that's like the big reveal. How do you see those people feeling afterwards?
Betrayed.
So betrayed. They're like, because in their minds, they've gone already 10 steps ahead, right? I feel like we're sidestepping into different issues here, but that's part of the mentality of lotto winning, right? Like you're viewing your life, the spending before it's even in your pocket. And then, yeah, it's taken away. That is a terrible, terrible prank. I have told my children, you ever do that? The sound. Nope, not part of this family anymore. Not funny. It's just not funny. Okay. Yeah. My almost 13-year-old would say. Okay. All right, situation noise. Let's talk about that. So it is any kind of external distraction that will cause variability within groups that will obscure between group differences. Okay. So smells, sights, and sounds that might distract participants and increase within group variability. Okay. So the way we try to control for that, like, so think about again, can you guys come up with an example of that, of what that would look like? Situation noise.
It could be construction noise. That's like when someone's doing like a standardized test or like doing like a self-evaluation,
Right.
like outside, just
Right.
it's distracting.
I'm actually reminded of taking my GREs way back when the dinosaurs roamed the earth. And I went to this testing center where, you know, it's probably, I don't know if you guys have gone to testing centers like that, maybe for your SATs or how that works, but it's, you get tons of people in this room. They're taking all sorts of tests. Some people are taking the GREs. Others are taking like their contractor's license exam, like completely different. But you're in this little cubicle and you have access to your computer. They check your ID, you know, you're being filmed, like it's all very on the up and up. They want to make sure no one's cheating. And right next door, they were completely renovating the inside. So occasionally you'd hear ton of hammering, like hammer, hammer, hammer. And then it was a drill like, and I happened to be not in a like two cubby wall. There was one wall on this side, and then it was the actual wall of the office on that side, not one of those. So I felt like they were about to drill into my brain. That caused a lot of anxiety and unneeded pressure during that time. And I was like, can we make a note of the fact that there was like construction going on within 3 feet of me? Like that doesn't seem right. So as a researcher, you want to control for as much as that as possible so that your participants are not distracted. And then obviously if you've got like 500 participants, you can't test them all at once. So you want to make sure that on one day of testing, not everybody bombs it because of some sort of situation noise. So you try to keep it as even and controlled as possible to try to minimize that error again. Okay, another name for this specifically to try to minimize all of these solutions is the idea of power. And that is part of statistical validity. So if, for example, in the GRE prep courses, if they really worked to increase GRE scores, then the study would detect the difference. It would detect the difference between the GRE prep test and just a pep talk. Studies that have greater power can detect smaller differences, okay? This is, again, the larger your sample size, the more likely you'll be able to identify a difference between group, right? Because it's less about individual differences, you're talking more in generalities, okay? So this is the same idea, right? This is kind of a visual illustration of that. If you're trying to, you know, this is a study again with low power, you can only find a few things, right? You're just, do you guys see what I'm saying? This is a tiny light. So you've got to do a lot of this and searching and you're not going to see a whole lot. If you have a lot of power, obviously you're able to shine the light on a lot more issues. Even really small effect size can be found. Whereas this is that, you know, small power, you can only show really big differences. Those are still highlighted.
Sorry to side note, but I last night I have this like really giant flashlight and I thought it was super duper dead. And at like 2 a.m, it like turned on and like blinded me and woke me up and I was freaking out. That I just thought it was a fun anecdote. That was my night.
That would be a little scary to have like a light shining.
I thought someone was breaking in.
Yeah.
I did not handle it well.
No. It's funny you say that because last night, it was early this morning, maybe like 4:30, I heard a really loud noise and I was like, what is that? And of course, what's my instinct? I wanted to wake up my husband, like, go downstairs. I'm like, he's just going to kill me. So then, you know, I'm dead by an intruder around my own husband. Either way, I'm dying there. So I just sat in bed and I was like, and I realized it was our cat. Our cat had jumped and hit something. And pets, they're out to destroy you.
Little sneaky.
Yeah.
I know, I get it.
All right, so this is a similar table that highlights again all of the differences we just talked about, an example of it, and what question do you want to ask to try to minimize that error as much as possible. You see it through here. Okay, now it is also possible that null effects are just hard to find, but they can be just as interesting, just like Elizabeth said earlier, as a study that shows group differences. It's not because there's no statistical difference that it's a bad study altogether. The sad part is that null effects are very rarely reported in popular media. We've gotten to be a society that wants to see that statistical difference. Otherwise, we're like, well, why do we care? Why are we even talking about that, right? Well, sometimes no difference is really, really impactful to think about, right? And this is especially important to report them in the literature because we want to make sure to replicate it, right? So if they're not found, then how do we actually create another study that is either similar, the same, with a different participant group in a different location, right? That's important information. So if I know that GRE test scores don't seem to be effective in a really affluent area of LA, and then I test it out again somewhere that's more socioeconomically impacted, and then I see now, wait, there is actually a difference here. Now I'm taking the studies further, that there may be another factor that's impacting it. Do you see what I mean? So the fact that they're often not reported is problematic. It is an issue that we're seeing. Okay, so that is the end then of chapter 11. Let me just do this right here. Any lingering questions? Okay.
No, that summed it up.
We are going to end here because chapter 12 dives right into multiple independent variables. Just the first 3 slides will take me about 20 minutes. So we're going to hold off here. Your goal is to keep recruiting. Make sure you get all the participants for your study. Talk to your group members so you know who is doing what in writing up the results section and the tables. And then make sure that you get those completed by next week, Wednesday, no later than midnight. If you have
Awesome.
additional analysis you would like me to run, let me know, because I'm not psychic yet. I haven't figured that out. So if you don't tell me, I will not do it. Okay?
Awesome. Okay. Quick thing before everyone signs off. I did grab everyone's surveys from the chat. If my group, should I add ours to the chat? So okay.
Yeah.
Okay, I got it. Just gonna go. Okay, awesome. Thank you. Okay, I
Okay.
will be doing the other surveys right after the class.
Sounds good.
Double thumbs from Kyle.
You got a thumbs up from Lawrence. That's good. All right.
Yeah.
Talk to you guys later.
All right, have a great one.
You too.